So, welcome to our second talk for the OSH monthly talk series. We're launching the series as a monthly talk series from here on out, but we're doing a couple right at the start as part of Open Hardware Month. So, if you haven't checked out the rest of our Open Hardware Month events, you can check them out on our website. And today, I'm Lee Wilkins. I'm the summit chair for the Open Source Hardware Association, and I'm here with Sid.
Hi, I'm Sid Dermay. I'm the community manager for OSHWA, and today we're going to be talking with Keenan Johnson about the Ribbit network. So welcome,
Awesome. So,
Keenan.
yeah, Keenan, do you want to introduce yourself and introduce your project and your team?
Yes, hello. Hi, my name's Keenan. Thank you both for having me, and it's great to see everyone, on the recording or live wherever you are in the world. My name's Keenan, and I'm here to talk about Ribbit Network. So I'm an engineer. I got a computer engineering degree, and I've sort of had a very myriad of a career. So I started off working in aerospace. I worked in really cool, super technical, hard stuff. It's really intense engineering
Mm-hmm.
and some of the coolest kind of engineering that you could do. And I did that for a really long time, and it was super fulfilling. But I kind of started to realize like I didn't care about it at all. Like it didn't help anyone that I knew or solve any problems that I really cared about in the world. And so I really wanted to pivot my career towards climate change.
Mm-hmm.
And so I've been able to spend the last like almost 10 years of my career working in startups around hardware focused on climate change. When I left aerospace, I founded a company to build really long range electric aircraft, which I think is an important part of like reducing carbon emissions. And I've done a bunch of things since then. But my latest sort of thing that I'm doing is this nonprofit, which is Ribbit Network. And it started out with, just sort of me like working on the project alone. And decided to start publishing it in open source just for like somewhere to put the project technically. But kind of as it grew, it's really expanded into like, I think open source is like the right exact way for this project. And making a nonprofit, like a formal 501c3 around the open source project and community really made a lot of sense. And I think it's one of the best containers to sort of organizationally house like where an open source project for hardware might live. So that's a little bit about my journey, and I can talk a little bit about like what is Ribbit Network and who's
Yeah.
the rest of the team and community there. So let me maybe just share a couple of slides just so we have some visuals to look at. So Ribbit
Mm-hmm.
Network, our goal, I guess my goal, and one of the questions I had when I started it is like, we talk a lot about emissions for climate change, specifically like carbon emissions is a really hot topic. You'll see it
Mm-hmm.
talked about in the news, like on the headlines all the time. So how do we know where they come from? Like we kind of generally know, right? Like
Mm-hmm.
like we know like your car or like power plants. Those things produce emissions, but like do we have like in my mind I was like the weather radar that shows where it's raining. Do we have that for
Mm-hmm.
emissions? Because it seems like that's what we would need to be checking like is what
Mm-hmm.
we're doing working, like as we're trying to deploy solutions, or like as lawmakers are trying to pass laws. All of those things should be based on data. And climate change is really interesting because we know exactly what is causing the problem. It's greenhouse gases. There's no real
Mm-hmm.
debate about that, and it's just about solutions. So at Ribbit, it's like, hey, we should have that feature based on open data that allows everybody, citizen scientists, governments, corporations, to both take informed action, but then also be held accountable for that shared action, because climate change
Mm-hmm.
is this big shared resource for the earth that we live in.
Can you talk a little bit more about that idea of like citizen science and how we're getting like why is it to you important that like individual people can like have access to this data as opposed to organizations that we trust and love?
Yeah. um, I think it's important for a lot of reasons. One is that we've known that climate change is a problem for a really long time,
Mhm.
and one of the reasons it's not solved, right, is it's not any one entity or person's fault. It's like this collective, really big systems problem that's, both like corporations have some part to play, us as individuals have some part to play, governments have some part to play. We've all been historically part of the problem, and we all need to historically be part of the solution, like moving forward when you think about the future. So,
and are there ways that like individual people can look at this data that like have a different vantage point or perspective than other organizations might?
For sure. Like, everyone has their own sort of experience and like, I would say journey that's taken them up to this point, that's given them all this great context for like how they can both like, add new data into a data set, but then also in the interpretation of the data, which is equally interesting because if you've ever worked on a data problem, it's like the data is not, it needs some interpretation to say like, what does this mean? Like ultimately you end up with some plots with some lines, right? And you're like, what does this mean? And so everybody's interpretation is going to be super different. And through that collective, like everybody's going to come up with a bunch of different interpretations. And if we can do that all in the open domain, then hopefully you can arrive at the most productive ones later.
Yeah, I think that's really interesting because I think a lot of people tend to view data as this objective source of information, but it's definitely, like you can tell a lot of stories with data, and anyone who's worked like intimately with data projects knows that. So,
yeah, of course. And I think it's really important, for it to be open because one, that allows like, infinite contribution and access that's equitable. And like, when we think about climate specifically, like, we want to make sure that our transition to a clean energy, like climate future is just and equitable. And one of the only ways to do that is to like have maximum transparency about like what is happening there.
Yeah, for sure.
And two, like the only way that we can establish like, hey, whose analysis of this data is correct is if we can establish like trust. And the best way to establish trust is through transparency of action. And so that's where the open source movement really aligns super nicely with the project. So we need to be able to like say like, hey, here's the data, here's exactly how it was collected, here's exactly the hardware that it ran on that's important and for how it was collected. And that's where the, the open source hardware movement is really important. And I think one of the reasons why a commercial company could never do this super easily, because it's very difficult for a for-profit company to say like, hey, here's our entire situation, like from the hardware and software, like we have no secrets, like go, like everyone, like it would be difficult for them to like establish a business model around this kind of thing. And that's why I think the nonprofit open source movement and community can be really helpful.
Right.
So, we're a big community. Like I said, we have a core team of volunteers. You can think of this as like maintainers, if you will, for any open source project. We have I think about 150 people in sort of the larger community, which is focused around GitHub and then Discord as our chat program right now. And then the core team is committed people who are, spending significant effort like weekly on Ribbit. So we've got people who are focused on software, hardware, community, data, and then sort of like research and outreach to different organizations. And so if you're interested in this project and want to come join us, we're always kind of looking for people to join and community, like contribute in whatever way you can. A lot of the ways that people start is by building your own sensor as kind of a first step. That's a good like first entry point into the project. And so I'm sure we'll have links in the notes and everywhere that you can come find us. If you join ribbitnetwork.org, you should have all the links to join the community and get involved. So if this is like an interesting and compelling project to you, either as a technical person or a non-technical person, like whatever your jam is, like we probably have things that you can help out in doing, because a lot of the work that we have is technical, certainly, but we have a lot of non-technical work to do outreach, to go figure out like how do we use Ribbit Network and this data most effectively in the world.
So I think it's a good time to maybe talk a little bit about like the physical, like you say, build your own sensor. So like, what is the sensor? How many people have built one?
Yeah, so this is the sensor. So the sensor is kind of like the hardware component of what we do, right? So we call them frogs. They're little frog sensors. They're a small sensor that is, fully open source hardware that you can go and build, and it uses a tiny laser sensor to measure pretty accurately the CO2 in the air. We call it frogs. That's kind of the name of the project, is because frogs are one of the species that are most affected by climate change. So they're super
I was wondering.
Yeah, they're super temperature sensitive in their habitats, and that means you'll hear scientists and like ecologists talk about indicator species for like changes that are happening. So they're a really good mascot for climate change, but also frogs are cool because they create like this vocal network of information with their little ribbit noises that they make to each other. That's super dense and information heavy, and that's exactly what we want to do with Ribbit Network. You can imagine all of our frogs are ribbiting out all the data for the network together.
I love that analogy.
Yeah, totally. So, we have all of the mechanical and electrical design files are hosted available. So we use this program called Onshape, which is a great, awesome CAD tool for like open source projects because it's freely available for public things. Anybody can use it for free in your browser, and you can go in here and fork the mechanical design if you want, which is exactly the same as the GitHub concept of fork if you're used to that, and kind of modify it and take it and make it your own. So it's super perfect. And like we can peel this apart real quick. So inside of the frog, we have classic single board computer. We use a Raspberry Pi CM4. So you can see it here on the carrier board alongside the big antenna. The big antenna is really important here. And the reason why we use the CM4 today is because these sensors go outside. And so oftentimes the Wi-Fi strength in citizen scientists' homes is not as strong as it is inside the home outside. And so it's really nice that the CM4 has this good pre-certified high gain antenna from the FCC, which we can use. Also just mentioning the enclosure here. So we've designed the enclosure it's a fully 3D printable enclosure. We recommend using a recycled PETG material, which is it's very similar to the material that like a water bottle is made of. And you can get good recycled versions of that. And equally, it's recyclable at the end of life. So it fits very nicely with the ethos of the project. And the 3D printing is a nice like lean manufacturing method that has almost no waste. If you kind of look at the top like head of the frog here, you'll see it's got these interesting fins. And the reason is we need to allow airflow up into the actual sensors of the frog, but we need to keep it protected from the rain and weather and solar radiation and everything. So this concept is called a Stevenson screen. If you type that into Wikipedia, it's this concept of having these like layered, I'm not even like overhangs, I guess. And it's been used in like metrology for a long time as kind of the way that you house outdoor sensors. So it's a super cool idea, and it's historically been made of like wood slats. We do it with 3D printing here, which is nice.
That's really cool.
Yeah. So they fit on top with these like really nice clips that you can see as you kind of take the enclosure off. And the top bit is where all the actual sensors are for the CO2, barometric pressure, humidity, and then a GPS sensor to locate the sensor spatially. So, yeah.
Have you, of course the question's going to come up right now with like the chip shortage.
Yeah.
So the Raspberry Pi, what are your thoughts?
The Raspberry Pi is great, but it has some real drawbacks, and that's the number one challenge that the project has right now in terms of like, how do we deploy this, is you cannot buy this Raspberry Pi easily. Like Ribbit Network was very lucky. We were able to do a bulk purchase of some of the CM4s together. So you can buy a small amount of the Raspberry Pis through us today, but we have a limited quantity, and we know that that's a stopgap and it won't last very long. So one of the big efforts that we have right now is to re-implement all of our software onto a microcontroller, which is good because it lowers the cost. It's something that we can source easily. We are trying to look at an ESP32 based design, and that's one of the big ongoing pushes on the technical side right now. So you can imagine, I have one here. This is the ESP32 Feather S3 from Adafruit. This is probably the board that we will go with, pending like the completion of the software. And so you can imagine the whole frog will probably get a lot smaller as that board decreases in size. You know, the challenges of like all the software to do a big distributed remote IoT fleet that anybody can join with a microcontroller, there's a lot of software to be written that enables that. We've been really lucky to work with this partner called Belina, which is an open source IoT fleet management service. And they support single board computers like Raspberry Pi. And we have an open fleet with them, which is really awesome because it means anybody can like image an SD card. And we have instructions for how to do this on our GitHub. But if you check out our GitHub, the frog sensors, all the hardware and software instructions are here.
Oh, awesome.
And so as part of like the assembly instructions, we've got good stuff here, but like talks all about like, hey, here's what you would do to like 3D print your own sensor and everything here. But as part of the software, it shows you how to like, hey, here's where you go. You can add a new frog if you want, and you can image an SD card. You can join it up to our shared Ribbit network fleet. And then everybody's software in the world gets our shared software updates. And building that workflow for a microcontroller is not something that we can use any like solution that exists right now. So we have to kind of build a lot of that infrastructure, which is the work that we're doing now. So if that's something that you're interested out there listening, come help us build it, because that's, I think, a really key enabler for the project right now.
Yeah, that's a super interesting problem, and I'm sure some folks will come out of the woodwork with thoughts and opinions. How many people are in the network right now, or how many sensor units are there?
So I think there's been about 40 or 50 or so that have been either built or deployed. If you go on like our website here, Ribbit Network, we've got a link to where you can view the live data. You'll see that the actual number of live sensors is quite less than that at the moment. And that's because like, I think that's a little bit natural. The sensors come on and offline. And part of that's like, you know, we need to improve the engineering of the sensor, certainly. So it does a better job of like alerting you, for example, like if it's not working or like you forget to, you turned off the light switch that it's on. But it also speaks to like, we really need a super high density of these sensors. So, you know, when I talk about it, it's like, we really probably need like one of these sensors on every major block of every city in the world. And I think that's doable. Like, to be honest, like that seems like a really big, hairy goal. And I think it'll take us a while to get there, but I think it is possible, like at the cost that we're talking about. Like these things cost less than a streetlight, for sure. And so like, it's super doable to get there in that future.
Yeah,
but
can you tell us a bit more about the software that you're showing us and like a bit more about the data visualization, and we can dig into that a bit?
Of course. So this is our data site. This is sort of the other half of what we do. So like all the sensors, right, are contributing all their data up to this big database. And then we have this website which renders and kind of displays the data on a map. You can think about this if you're familiar with the project Purple Air. They are an air quality monitoring software. So that's particle matters, not greenhouse gases. This is sort of similar to that. But you can click on any one of the sensors on the map and get these like nice plots about like, okay, what's like the CO2 related in the day? What's the temperature, barometric pressure? You can change the time scale of this to like the hourly level if you'd like, or like the 1 day kind of period, whatever you're interested in seeing. You can export that data if you'd like. One of the things that we're trying to build out right now is a proper API to access this data, because that's going to be really important for everybody who like research organizations or universities or schools who want to gain access to this data and do some interesting analysis with it. We want to provide that. And we just have kind of like direct access to the database right now. So this is all also on our GitHub. It's all open source. If you check out our dashboard here, you'll find all that code and everything that powers this dashboard. We have a pretty simple like stack, I would say, compared to a lot of modern like web apps. So this will certainly get more complicated as we grow. So we've got all our frogs kind of over here. We use InfluxDB, which is a really awesome open source project as well for time series data as our database. And then sitting on top of that is this Dash app, which is basically a Flask app with this really awesome plotting library, Plotly, integrated into this framework called Dash, which makes it really easy to render those web pages with the nice graphics and maps and things.
That's awesome. You mentioned this a little bit already, but if you want to expand on like other projects or open source communities that kind of inspired you, or things that like you're drawing on or maybe collaborating with.
Yeah, that's a good question. I think there's a lot of open source communities that I think are super inspiring. You know, one on the hardware side, like there are a lot of really awesome active communities around development languages and technical implementations. And I think that we've taken a lot of inspiration from those in terms of like how do open source communities like operate and like what does the community look like that functions well. And we're definitely still learning for how that goes. But like, for example, the concept of like having a core team of maintainers, that's sort of a best practice that's come out of a lot of the open source community efforts. There's a lot of really awesome open data projects in climate. So Ribbit Network got the chance to be part of an open data accelerator based in the UK called SUBAC, which I will plug. It's like subac.org, so SUBAK.org.
We'll definitely get the link out there.
Yeah, we'll find it. And they have this open data catalog. And it's got all kinds of open data organizations that are publishing their data sets into the public domain for climate. And that's been a big like partner and inspiration for us as well.
That's awesome. Do you so I see that you have these like, you know, you have these sensors that are very specific and you have this core group of maintainers, but like a growing budding community.
Yeah.
Have people like riffed on this idea or made changes that you've implemented into the core? Like, can you tell us a bit about that back and forth?
Yeah, for sure. So the core group is kind of like they're just sort of the psychological like steering committee, right? But then we have a whole big to-do list, both technical and non-technical. And all kinds of people have jumped in and done random things, whether it's like we've had people do cool things like our bill of materials, which is like the parts list for any hardware project. One of the really big challenges with a global open source hardware project like this is that list of parts and like where you can buy them is often super different depending on what country you live in. Yeah. And so people have done random things like translating that bill of materials into like, hey, here's one, you know, that works in France, for example. Like that's like a cool contribution that people have made. And it's definitely a community effort. Like I think we have almost 150 people in the like Discord chat, and a lot of those people have contributed in various ways. But you can also see sort of like we try to keep this contributor wall here up to date on each of the actual repos for people who have submitted different things. And all kinds of people have done like tons of awesome contributions into the project.
So it's a bit of like a meta question, like what how did you, because I know one of the biggest challenges for like you at the beginning, you really talked about how there was something that was really important to you. So you decided to start this nonprofit. And it's always really hard to get people to care about your specific solution as much as you care about it. But it seems like you've really managed to inspire people. So like, how did that come about? How did you get this core group of contributors?
Yeah, I don't know. I'm a little bit like unsure sometimes as well, like what I've done to convince other people to come work on it with me. I think one thing I think that's been important and a key to our success is being honest about like what we know and what we don't know. And like one of the great things about being a sort of open community like this is there's a lot of things like we don't know. And joining this effort is like just joining on the journey to go explore and like learn those things. Like, you know, there's a ton of questions about like how to interpret this data and like, will it work? And like, what's the best way to do it? And it's like, I don't know all the answers. And like, we really need the collective intelligence of a large community to like figure that out, certainly. And so I think being really transparent about that has been really helpful and compelling. I think people appreciate sort of that like honesty and ethos, because it's really missing in a lot of like community projects or like, you know, most people are used to working in technical environments where there's a lack of transparency and honesty with, you know, different vendors or companies or like whatever it looks like. And that's really been refreshing, I think, for a lot of people. And then two, just like, you know, this project is important. It's easy to, it's a non-scary way for you to contribute to a very scary problem that we face, being climate change. And that's one of the reasons why it's really important that it's fun and cute. The sensor looks cute. It's fun. We try to be very welcoming and like make this a solution-oriented like approach to a very like a very intimidating problem the more you look at it of climate change. And we've seen that this like fear-based messaging of like, oh no, something bad is going to happen is not motivating. Like it doesn't work for like most people. We've been trying that for like 30 or 40 years for climate. And so anything that's focused on like a fun thing that you can really do that like hopefully will be really helpful on the data side for climate. But even if it's just like, hey, you know, you've come in, you've kind of learned a little bit about frogs and like had some experience with the data and like with climate in general in a non-scary way, that's a win. Even if no other goal of the project succeeds, like if we can just give people those experiences, also great, because there's a lot of other things that you can do in your life and like steps that you can take, whether it's, you know, campaigning for the legislation that you care about or like making a small lifestyle change. All those things in aggregate will, you know, be super important and impactful for climate. So yeah.
I mean, I feel very inspired to make changes here, hearing you talk about it. So I'm not surprised you rallied a community behind you. One thing I was also wondering is, were there any, because you say it takes like the collective ability of everyone, the collective knowledge of everyone to create these things, and you've also outlined a number of like really challenging technical hurdles that you're in the process of overcoming. So I'm wondering if there was a technical challenge that maybe like you thought you couldn't overcome, or you thought, you know, like you really needed help and you managed to overcome it in kind of like a clever, interesting way, or a part of the design that you're really like proud about figuring out. I'd love to hear about that.
Sure. Yeah, I mean, so many. Like when I made, you know, it was just me in the very beginning, and I tried to build the first frog. I was like, I'm really like, I don't know how to build like an enclosure for something that goes outside. Like I'm not a mechanical engineer that is good. And I was like, I don't know what to do. And so I started, you know, how most I think electrical engineers start with a project. Was you like buy one of those like kit boxes, which is like, you know, a plastic thing, and then you kind of like crappily drill some holes in it for like the wires to go in and out, and like that kind of works okay. And you know, I think that was one of the first places where I started asking for help. You know, this was before it was decided that it was going to be a nonprofit or a community or anything, but it's just like, oh wow, I don't know like what I'm doing. I feel like I know there are better ways to do this. I have no idea, like, you know, what even. I was like, oh yeah, like we should 3D printing, like maybe we could do that. But like then I asked a couple people, and they're like, oh well, yeah, like if you put the normal material that people 3D print with outside, it'll just kind of like melt and like be bad. And I was like, oh man, like I don't know what to do then. And like I also don't know how to make an enclosure for something that goes outside. It needs to be waterproof, but also let air in. And so like that's like a really good example of like I engaged with some really awesome mechanical engineers a lot of them have come into the community and are now part of the core team to help solve that problem. Because there really, I think, are very few examples of like how do you build an outdoor electronics sensor and like from the full stack with the enclosure and everything. And think about things like we've thought about like waterproofing electronics is difficult. So like conformal coating, for example, we have like a strategy for like all of that stuff, the enclosure, conformal coating, the whole thing on the electronics side, which is, I'm not aware of any other single open source project that does that. That's kind of the work that's only done in for-profit companies and products that get siloed and never heard from again. And so like I'm super proud about that effort in particular because I did not know what to do about it in the very early times.
That's really great to hear. I feel like I agree. Like every time I've ever had to do like water or like weatherproofing hardware, everyone's like, just put it in a Pelican case. And it's just not always practical to do.
Yeah. And this project specifically, it just like wasn't possible because like the thing would not work. If you did that. And so it's like, all right, like gotta figure out how to do this.
And has it been tested in like because obviously it's meant to go like around the world. What kind of environments has it been tested in?
So we've had them in at least 7 countries that I've been able to track. We have people who live kind of in all parts of the world. Like I live in Seattle, Washington in the United States. So we are chronically moist as an environment, I would say. So that's been really great. We have people who've kind of put it in the cold and the hot, like wherever in the world and the kind of temperature swings that you are. And that's been really great also to kind of learn what works, what doesn't work. We've been through 3 big iterations of the sensor. We've got a bunch more planned. And all of those like sort of learnings about deploying those first sensors have been really valuable because, like just like software and hardware, the number of iteration cycles that you get is basically the best predictor of like, how good is this thing? And it's really, kind of phrasing it as like, okay, we're going to sit down and we're going to think about it hard enough until the design is done. Like doesn't work. Just like it doesn't work in software, it also doesn't work in hardware. So like being able to have people actually using the sensor in the real world and figuring out like what works and what doesn't is super important.
Yeah, I mean, it's such a huge difference to like run. Like I'm in Montreal. It gets like really, really cold here. And like running. I've also tried to run electronics in like tropical places and really warm places, and it's like a whole other. It's challenging. It's just a whole other set of challenges. So
for sure. And that's really exposed some of the things that we want to do in the future, which seem easy if you're not considering like all global climates, but hard when you start doing that. So like a solar powered frog is something that we would love to do in the future. But like the challenges of like, how do you do a battery powered solar thing that also might exist where you are in Montreal in the very cold winter environments? There's no easy answers for how to do that. Like you can't go onto pick your favorite open source electronics distributor and buy all the components and put it together and have something that will function in those environments. Like it won't work. And so like, that's another really big, hairy, challenging problem that we have to like dig into is like, what's the right way to do that? Like we think that it's possible, but requires a lot of hard engineering work to get there. And if we can do that in the open source domain, I think that'll be a big win for everybody in all kinds of projects everywhere that like maybe want to do something similar, because there's tons of other great ideas that people have about like how to do open source IoT outside sensing. Like that's like a pretty generic problem statement, I think, in the world. And there just aren't examples of how to do it well, like in open source hardware.
Yeah, I feel like everyone's got kind of like, sense your garden water, these kind of like dip your toes into it, but making it robust and like trying to figure out how it could actually work in a scalable way is like, it's the real challenge. And
it's hard work. Like it's not trivial. Like that it's not to fault anybody's like random project. And I think that's really highlights the difference about like, where can you go with a certain thing as one person versus where you can go as a community of people. Like really, like to do a project like this well, it's a team effort that requires different engineering disciplines and expertise all chipping in at different parts of the problem for a while. And that's where I think the strength of a community and an open source group like this will really take it much farther than most individuals can.
Yeah, I love the story. I love seeing the arc, and like I'm really looking forward to seeing the map become more populated. Maybe
Yeah.
I'll build one here and join the network.
Of course. Yeah.
On that note, just as we're like getting towards the end of this, do you want to just talk about what your next steps are with Ribbit and where you're looking to go?
Yeah. So our main goal for the rest of this year, hopefully, is to get that microcontroller based version of the Frog up to like kind of the MVP version, so that like people can like easily buy the sensor parts and build it themselves, because it's kind of challenging to do it right now because the electronic shortage. So that's our main first goal. What we want to do after that, hopefully early next year, is be able to start offering like kits to put together these sensors. Right now you have to buy all the parts from different places, and it's kind of confusing, especially if you're like a non-technical person. And one of the things that we'd really like to start doing is start partnering with different schools all over the world and offering sort of like some curriculum around like, hey, here's like how you put together a Frog sensor kit. You have like a build day where you learn how to do it. You check in on it like maybe every like once a week for a couple weeks, and like have some experiential learning process there about our environments. And we've got some good partners, I think, like school districts, a few that are like ready and willing to do that as soon as we can offer like enough kits to sort of support them. And so that's why getting that first sensors with the microcontroller up and running is really important. And hopefully start doing that in a way that's repeatable next year, as well as continuing to like make it easier for our citizen scientists to deploy. And then once we have enough sensors going, hopefully in the next year or so, like really starting to do some of that super interesting data analysis. So being able to build like real-time sort of infographic style kind of heat maps for a city would be super excellent. And that's something that we really want to do with the sensors, hopefully next year. And yeah, we're thinking about crowdfunding as well to kind of do a big push to do like a bulk buy to like fund some of those kits so that we can drop the price perhaps for anybody who like wants to purchase a kit. All of those things are kind of in the cards for us, as well as like, who knows like what great community members who might be excited, like kind of take the project in different ways as well. And I'm really like just interested and hopeful to see like what kind of things people do with the project.
Yeah, for sure. Like if you just to like, I know you mentioned throughout this a bunch of different ways and places that people could go, but if you would just do like a roundup of like people who want to be involved, where can they go?
Yeah, so the easiest way to get started is ribbitnetwork.org. If you put that in Google or your favorite search engine, you should find it. That has all the links. It has all the links to our social media. The two most important links, though, if you want to get involved, are like do you want to join the community? If yes, like here's the GitHub link, here's the Discord link, whichever flavor of community like platform that you prefer to engage in, like you can do that. And if you want to start building a sensor, for example, here's the link to the best and greatest instructions for how to do that. If you do build a sensor, we encourage you to like get involved with the community as well, because that's sort of like the most fulfilling aspect of the project. And your like experiences building it only make the instructions better because we're constantly improving those. So ribbitnetwork.org, and then you can join the community there, find the instructions to build a sensor. All of that stuff is available there. So that's where I would plug.
Awesome. Well, thank you so much, Keenan. This was really, really great to chat with you. And I am really excited about the project and really excited to watch it develop.
Yeah, thank you. It's great to, chat about it. I love talking about this, and I love, open source hardware and communities and design and engineering. So don't be a stranger for anybody who wants to get in touch. You can find me on Discord or on Twitter, or whatever social media you prefer. And please reach out if you have questions, ideas, want to chat. I want to hear all of it. So.
Awesome. Thanks so much. And thanks for being on the stream.
Yes. Thanks, everyone. Have a good rest of your day wherever you are.